Number 18. Exact value. Anytime I say exact value, that means not just a calculator. You're going to give me in terms of radicals. So we usually did quadrants and reference angles. What quadrant is 5 pi over 6 in?
Quadrant 2.
Yes. And reference angle. You can say pi over 6, or if you prefer to think in degrees, that's 30 degrees. Okay. Secant is the reciprocal of cosine. In quadrant 2, is cosine positive or negative? Negative. Okay, the cosine of 30 is what?
Radical 3 over 2.
So secant would flip it. So we get -2 radical 3 over 3. And please fix anything as we go through if you need to. We didn't ask about 19, but can I talk about it? I know a lot of people were confused yesterday. The 4 on the outside is just going to stay. I need to evaluate this inside part. Anytime we had a negative angle, what did we typically do first?
Add 2 pi.
If we are in degrees, we would add 360. If we're in radians, we add 2 pi. You don't have to, but that makes it a little bit easier. So then it tells me that's 5 pi over 4. What if I'd said something like find the cosine of 510 degrees? What would you have to do? Subtract 360. Okay, so we can always add or subtract 360 in degree form or 2 pi if we're in radian form. All right, then what quadrant is 5 pi over 4 in? 3. Reference angle is pi over 4 or 45 degrees. In quadrant 3, is cosine positive or negative? Negative. And the cosine of 45 degrees?
Radical 2 over 2.
So if you multiply, you get -4 radical 2 over 2 or -2 radical 2. Right. Problem 20. Exact value. That tells me in radicals. But when I look at that, that's not one we recognize, is it? Let's go ahead and just change it to degrees since that will be easier to work with. How do I convert radians into degrees? Pi's cancel. 5 over 12 times 180 gives us. Okay. Remember, we have a formula sheet. This can be found by doing 30 plus 45. Right? So think about on your flip chart, this is the sum and difference formulas. So the cosine sum formula is cosine of the first, cosine of the second, minus sine of the first, sine of the second. Straight from the formula sheet. Anytime you get stuck and you don't know what to do, look at your formula sheet and see if something would help. Cosine of 30. So that would be square root of the bottom over 2. Cosine of 45. Sine of 30. And sine of 45 equal 2 over 2. So if we multiply, we get radical 6 over 4 minus radical 2 over 4. You can leave it like that or write one fraction. Either way is fine. All right. Problem 21. So now we're getting into closer to the proof type problems. This one, we work it the same as the proof. It's just a little bit harder because we don't necessarily know what it's equal to. What's always a good starting place? Sine and cosine. Cosecant is cotangent is cosine over sine, and tangent is have to know those ratios, and I think everybody does at this point. But if you don't or you're having any trouble, please let me know there. From this point, to divide fractions, we flip and multiply. This is like sine over 1. So if I flip and multiply, the top one stays the same. You flip the bottom. So I get 1 over sine squared x minus cosine squared x over sine squared x. What do I do now? We have a common denominator, so we can make one big fraction. What is 1 minus cosine squared? Sine squared x over sine squared x gives us 1. All right.
Did you also do 16?
Absolutely. Okay. I want secant, and all I know is that tangent is 3/4. What we can do is triangle. It's kind of, we forget because we've done so many more complicated things, but remember the first half of the class we were really drawing right triangles and doing SOHCAHTOA all the time. We're in the third quadrant, so if I set this up, tangent is opposite over adjacent. What's wrong with those numbers though? Yeah, if you go back and down, both of those would be negative. All right, then we could find our missing side, Pythagorean theorem, because we have a right triangle. So -3 squared is -4 squared plus c squared. Hypotenuse, remember, is always positive, so c has to be 5. If it weren't the hypotenuse, you decide if it's positive or negative based off the quadrant you're in. So then secant, we can think that's a reciprocal of cosine. Cosine's adjacent over hypotenuse, so this would be hypotenuse over adjacent. So -5 over 4. What is secant? Minus tangent, sine over cosine, times sine. Order of operations. Do we subtract or multiply first? Multiply. What is sine times sine? I have 1 minus sine squared x over cosine x. But 1 minus sine squared is? And so when you divide those, what do we get? Is this helping everybody? Different options here. Did most of you go to sines and cosines? So tangent we know is sine over cosine. Cotangent is cosine over sine minus cosine. If you distribute, if you take sine over cosine times cosine over sine, what happens? Everything cancels and we're left with 1. Okay, when I multiply it to this one, the cosine on top and bottom cancel, so I just get 1 minus sine x. It's not sine squared, so I can't change that to anything else. That is my final answer. All right. 25. Now we got into the actual proofs. It's really the same as what we have been doing, but easier because we know what the right answer is. Remember, we boxed in one side, so I would box in the right here. If you want to add or subtract fractions, what do they have to have?
Common denominators.
So the first one needs a 1 plus cosine x. So I'll multiply that on top and bottom. The second one needs 1 minus cosine x. We have to do it on top and bottom. So how do you take 1 plus cosine x times 1 plus cosine x? We have to distribute everything out, so FOIL. So we get 1 plus cosine x and plus cosine x would be 2 cosine x plus cosine times cosine is cosine squared. On the bottom, if you FOIL, you get 1 plus cosine x and minus cosine x cancel. Minus cosine squared. Right, second one, we're multiplying by 1 minus cosine. So we get 1 minus cosine and minus cosine is minus 2 cosine x plus cosine squared x. And on the bottom, we FOIL and get 1 minus cosine squared x. Now remember, we are subtracting. So if we change this to a plus, run a negative through. Then 1 plus negative 1, that cancels. Cosine squared and negative cosine squared cancels. 2 cosine plus 2 cosine is 4 cosine over 1 minus cosine squared x. Look at our goal. Where could we go from here?
Turn the minus cosine squared x into sine squared x.
Remember, we talked about how you can separate these things off. Sine squared just means you have 2 sines on the bottom. So you don't necessarily have to write this step. It's just kind of visualizing what's happening. So we have a 4. A cosine over a sine is cotangent, and 1 over sine is cosecant. And that is what we needed. That's it.
Can we use what he said?
Absolutely. Is that one okay? Let's talk about 26. So we got into all of the graphing questions from here. I did put a question on the study guide that said, like, make sure you know what all the graphs look like. You know, obviously that's just one chapter, so you're not going to have 6 or 7 different graphing questions on there, but I could easily ask you a couple. I could ask you just some basic questions, like can you look at this and tell me what the amplitude is or what the period should be? Can you match, if I gave you the equation, could you match it to the graph, you know, recognizing those basic shapes. So those are the types of things that we would do. But you should expect at least one question where you have to do all of this stuff to list everything out. So amplitude, where do we find the amplitude? That's the number in front of cosine, so that's a 3. Period. Remember, everything except tangent and cotangent has a normal period of 2 pi. To find the actual period, you take your normal period, divide by the number in front of it. So 2 pi divided by 2 is just pi. How do we find the count by? Good. Whatever answer you get for your period divided by 4. Interval. You have to do the interval if you have anything added or subtracted in here, but it's never a bad idea. So you could do it on every question if you wanted. So everything except tangent and cotangent typically is graphed between 0 and 2 pi. So we set up the argument, the thing in the middle, and 0 and 2 pi on the end. So then if I solve it, I add my pi over 3. And then I have to go through and divide everything by 2. We get pi over 6 less than or equal to x less than or equal to So now I'm ready to draw my graph. Do you remember how many points did we need on the x-axis? 5. My first one is where my interval starts, which was pi over 6. And we did 4 points after that. How do we get those points? Add the count pi. Remember, if you get hung up on the fractions, use the calculator, but don't plug in the pi. Just do like 1/6 plus 1/4 and throw the pi back on your answer when you do that. So we get 5 pi over 12. Nope, 2 pi over 3. Okay. 11 pi over 12. 14 pi over 12, so that's 7 pi over 6. And you notice this last number is where we set our interval within. Amplitude is 3. So I'm going to, it's centered around 0, we're going 3 above and below that. Okay, how does the graph of cosine start? At the top. So at pi over 6, I'll be at 3. Guys, if you're not sure, use a calculator to help you. You would need to be in radian mode, but you could certainly plug this in to your calculator. Plug in pi over 6. We're just plotting points, essentially. So you could double check yourself if you needed to. Just plug in that value. The cosine starts at the top, hits 0, low point, back to 0, up to our high point. And so our graph looks something like this. And remember, sine and cosine, they're waves. They keep going forever. So this isn't the end. We are just graphing one period. So that's why I'm able to stop there. Okay. 27. This one is flipped a little bit, but same thing as if I said -3 tangent of x minus 2. First of all, what does a negative in front do? We'll flip our graph. What does a minus 2 do? Okay, your amplitude is always positive. It's just the number in front, so my amplitude is 3. Tangent and cotangent have a normal period of what? Pi. And it's just pi divided by the number in front of x, which is 1, so our period is pi. Count by is period divided by 4. So we're counting by pi over 4. All right, interval. You don't have to do it here, but you can. Where do we graph tangent? And your argument, the angle in the middle. Cotangent goes from 0 to pi, and everything else is 0 to 2 pi. Okay. So my points on the x-axis, I'm starting at negative pi over 2. If I add pi over 4 to that, I get negative pi over 4. Add pi over 4, we get 0. Pi over 4. And then pi over 2. How did we do the down 2? So our graph is going to be centered down here at negative 2. My amplitude is 3. That's measured from this line. So we'll go 3 above and 3 below. Okay, we picked this interval because what happens on both ends? And 0 in the middle, but my 0 is down here. Now tangent is typically increasing, but this one was flipped, so it will be decreasing. So at here I'll be at 1, and down here I'm 3 below. Okay, so I sketch this. Should be approaching our asymptotes from there. So I put several graphing questions on the study guide, not because I'm going to have a ton of them on the final, but because we had different types, Remember, sine and cosine were kind of the same, tangent and cotangent were similar, and secant and cosecant were similar. So I wanted to jog your memory on all those types. Is this one okay? Okay, so on this one, what does the 1 in front do to my graph? Okay, what is our amplitude? Period. Normal period is 2 pi. Divide by the number in front of x, which is just 1, so my period is 2 pi. Remember, everything except tangent and cotangent. Normal period, 2 pi. Count by. You take your period, divide by 4, so we get pi over 2. Interval, not necessary here, but if you did it, we just set up between 0 and 2 pi, and my angle is just x. So it looks like that. Okay. So my graph. Starting this at 0, adding pi over 2 each. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, we are going up 1. Amplitude is a half. So I'm going to go up a half from there and down a half from there. So to do this, remember we started off graphing sine or cosine. Cosecant is the reciprocal of sine. So we graphed sine to start. Sine starts at 0, up to its amplitude, back to 0, down, back to 0. So this is my sine graph. Okay, some of you lightly draw it in, some of you got to the point where you just put dots, but you need to know what that is, because every time that's at my center point, what happens on cosecant? High and low points stay. And then we turn it away from the axis. So this one goes up. And this section goes down. So that actual pink there is my cosecant. The rest of it's just what I use to help me get there. So remember, okay. Tangent and cotangent are very similar. Tangent, we go from negative pi over 2 to positive pi over 2. So that one had the weird interval. Asymptotes at the end. And then it was increasing. So it looks like this. Cotangent, we went from 0 to pi. I'm not sure why I put some inch points, but we did that because we have asymptotes on the ends. 0 in the middle, but cotangent was falling. The thing right here, that's like 45 degrees and it's positive there. So it looks like that. So sine and cosine are the waves. Secant and cosecant are like the cups, up or down. And tangent and cotangent kind of remind you of an x cubed graph. You know, they're like a chair.
Any other questions about the graph?
Is this helping or boring you guys? I don't want to go over things if it's boring, but if it's helpful, I want to keep discussing. Okay. 29. So on the final, I would probably phrase this question a little bit differently and say, find the exact value. And so exact value tells me, oh, I can't just plug this in my calculator. So what we talked about when we did these, We notice it's an inverse question, so it's one of our more recent things. And the answer to an inverse is an angle. And I'm asking you to find cosine of that angle. So yes, you could plug this in your calculator, but you're going to get a decimal answer. On the test, if I were really thinking, I would probably make sure it was one that involved a radical, so I would know if you used a calculator or not, so I could double check. What we could do is set this up. Sine inverse can either be quadrant 1 or 4. The 21 over 35 is positive, so I'm just in the first quadrant. Sine is opposite over hypotenuse. So we could find our missing side. A squared plus 21 squared equals 35 squared. And so when you do the square root of that, you get 28. So I solved my triangle, so now I want cosine. We know cosine adjacent over hypotenuse. So 28 over 35, which reduces to 4. Problem 32. I want sine of 2 theta. Remember, if we don't know what to do, where should I look? Formula sheet. On your formula sheet, it says sine of 2 theta is 2 times the sine of theta cosine of theta. Sine of theta is negative 4/7. We don't know cosine, so we need to find it. We can use the triangle. Sine was a negative value, so that tells me it's either quadrant 3 or 4, but cosine is greater than 0, so cosine is positive. So which quadrant do I have to be in? Cosine is going to be positive. I'll have to go ahead and do it in quadrant 4. Okay, sine is opposite over hypotenuse, so this would be negative 4 and 7. So that Pythagorean theorem. Hello. Alright, so we have a squared plus negative 4 squared equals 7 squared. So a squared equals 33, so this side is the square root of 33. So cosine, adjacent over hypotenuse, radical 33 over 7, so now if I multiply, we get 8, negative 8, radical 33 over 49.
No, that's okay. Did you feel so now?
33. Remember our cofunctions. Sine goes with cosine. Tangent goes with cotangent. Secant goes with cosecant. So remember, that's different than reciprocals. Those are the cofunctions, yeah.
On the last one, if we did it like, if we did the sine inverse or 4 over 7 and just plugged that in for theta, would we get that wrong?
I would. Okay, yes and no, maybe. Depends on if I said exact value. So if I said the exact value of it, I would take off for not having a radical. As this is written right now, you would get it correct because I didn't specify. All right. Cofunctions are equal when what's true about their angles? How'd it go?
Good.
They're complementary. So what's the cofunction for cotangent? That's tangent. And the angles have 90 degrees, or if we're in radians, they add up to pi over 2. So if we subtract that over, we get negative pi. So it's equal to the tangent of negative pi. Okay, 34. So we know the distance from B to C is the square root of 21. From B to D is 5. And A to D is 6. And we want this side. So it's tempting to think we have to do a lot of elaborate stuff because we've learned a ton this semester. But remember, everything doesn't have to be difficult. In here, I really have 2 right triangles. Okay, I have this little one, BCD, where this side is 5 and this side is the square root of 21. Could you find this side? How would you do that? So I call it y. Radical 21 squared plus y squared equals 5 squared. So that tells me this side is 2. Alright. The entire thing is also a right triangle. So if I look at the whole picture, we're trying to find x. This is radical 21. If this piece is 2, what's the entire side length? So we could do Pythagorean theorem again. A squared is radical 21 squared equals x squared. Square root. Make sure there's no perfect squares that go into it, and there's not. So you just get the square root of 85. So you could have tried, finding an angle and then doing law of sines or cosines, but we didn't have to work that hard. We could just do Pythagorean theorem a couple times to get started. Question 36. In triangle ABC. Okay, first of all, I didn't say right triangle. So can I do any Pythagorean theorem or SOHCAHTOA stuff here? No. I gave you the sides and I want the angle. The only thing we can use if we don't have a right triangle is law of sines or law of cosines. So question 35, we didn't ask about that one, but it also didn't tell us it was a right triangle. That would be a good one on 35 where you could have done law of sines. Like A over sine A equals B over sine of B. Because on that question, you knew both angle A and angle B and side B. So it's just a matter of plugging in and multiplying. Here, though, I don't know any of the angles, so law of sines doesn't work. I'm trying to find angle B. So law of cosines has 3 variations. Since I'm looking for angle B, I would use this variation. And then if we plug in, we get 5.7 squared equals 9.3 squared. 8.2 squared minus 2 is 9.3 times 8.2 cosine of B. And remember, we pretty much exclusively did this on our calculator, didn't we? So we could type in the 5.7 squared. We're going to subtract over 9.3 squared and 8.2 squared. And what will we have to do with all of this stuff? Divide. Are you guys okay if I just do all of that at once? Certainly could show more work if you needed to, and if you need me to, I can. If you do all that, you get cosine of B is equal to 0.79491. Okay, we know cosine is only positive in quadrant 1 and quadrant 4. Can you have an angle in quadrant 4 if we are talking about a triangle? No, because if you're in quadrant 4, it's between 270 and 360, right? That's too big for a triangle. So now all to do is cosine inverse. Make sure you're in degree mode so you get a degree answer. We get 37.35 degrees. So if we don't know it's a right triangle, that's when we have to do law of sines or law of cosines. Question number 37. If I'm trying to get decimals, so we have 97. Okay, 12 minutes. How many minutes are in a degree? So we divide it by 60. 52 seconds. How many seconds are in a degree? Think about time if you need to. 60 seconds in a minute, 60 minutes in an hour. So 60 times 60. So then if we type this in, we get 97.2144 degrees. All right. And 38. This is back from the first chapter when we had X, Y, and R definitions. Now, whether or not you think about that is up to you. You can do X, Y, and R. We could also set up a triangle. But what we have to do is find points that work. I know that X has to be less than or equal to 0. X equals 0 is just the center, so that's not helpful. So I need a different negative value. Think about it, you are going to have to solve for y, so we'll have to divide by 2. So let's pick an even number and avoid some fractions, just to make the math a little bit easier. So if I did that, maybe I want x to be negative 2. If I plug that in, that means my y is negative 3. Now, you might have different points than this. That's okay. We know the trig functions are the same for similar triangles, right? So that's all that you did differently. So you could have found r here. If you're more familiar with SOHCAHTOA, my x is negative 2, my y is negative 3. How do I find this other side? That side is the square root of 13. So sine, you can do the XYR definition or just think SOHCAHTOA, sine is opposite over hypotenuse. So negative 3 over the square root of 13 or negative 3 radical 13 over 13. Cosine was x over r or adjacent over hypotenuse. So negative 2 over the square root of 13 or negative 2 radical 13 over 13. Tangent is y over x or opposite over adjacent. So negative 3 over negative 2 is positive 3/2. Are there other questions that you guys have?
How do we know what quadrant that one was in?
We knew that the x had to be negative from this statement. And then when I solved it, I got my y to be negative. So if x and y were both negative, that put it in quadrant 3.
for X, you just choose the smallest number that would work with your other variables.
Yeah, that's usually what I do. That way you don't have to reduce as much later on.